Hi guys, welcome to this Relay Shield tutorial in this series of building your own Arduino Shields project from start to finish. This is a practical tutorial aiming at teaching you everything you need to know to build any Arduino Shield of your choice. In this video, we're gonna build a fully working Arduino Relay Shield. We'll start from scratch explaining and simulating the circuit diagram in Proteus. Then we're gonna create a printed circuit board with Eagle, but any PC board design software can also be used. Then we're gonna generate the manufacturing files to manufacture our PC board with PCBWay or your favorite board house. And finally, we're gonna solder the component on our board and test the operation with a simple Arduino sketch. Are you ready? Let's get started. So, what is a relay? A relay is basically an electrically controlled switch that can be used to control a high power circuit from a low power circuit. Many relays use an electromagnet to mechanically operate a switch, but other operating principles are also used, such as solid-state relays. There are many reasons why one can use a relay in a circuit. If you want to control high-power devices such as light bulbs or electric motors from an Arduino board, you can use a relay, as Arduino on its own cannot handle such high voltage and current. The other reason to use a relay is to isolate a low-power circuit from a high-power circuit. Relays isolate low-power circuit from high-power circuit. This is a good feature, especially for safety reasons. A section of the circuit with high dangerous voltage or current could be isolated from the user. Relays comes in different types and shapes. Here are some electromagnetic relays and some solid-state relays. In a solid-state relay, a solid-state electronic component provides a function similar to an electromechanical relay but does not have any moving component. A solid-state relay uses a thyristor, triac, or other solid-state switching device activated by the control signal to switch the control load instead of a solenoid. An optocoupler can be used to isolate control and controlled circuit. This is a symbol of a single-pole double-throw electromagnetic relay. This relay has 5 terminals. 2 terminals are used to energize the coil of the relay. This is the low-power section and can be connected to microcontroller pins. These other 3 are the controlled switch where we can connect our high-power devices. The COM is the common terminal. The NO stands for normally open and the NC for normally closed. When the coil of the relay is not energized, the armature will be connected to the normally connected contact. Thus the COMs and the normally connected contact will close the circuit and anything connected through this contact will be switched on. But when the coil is energized, it becomes an electromagnet and thus will attract the ion armature. This will open the normally connected contact and close the normally open contact. Anything connected through this normally open contact and COM will be switched on. There are a few parameters to consider when selecting a relay to ensure safety and proper operation. The first parameter is the coil rating. The coil rating is very important. This is the low voltage required to energize the relay. Some relays operate with DC voltage of 5 to 12 volt, drawing current of about 50 mA to 100 mA. This relay model, Omron G5LE-14, the coil is rated 5 volt DC, and from the datasheet we can see the current is 79.4 mA and the coil resistance is 63 ohms. The next important parameter is the contact ratings. These are the ratings of the high power terminals of the relay. This relay is rated 10 amp at 250 volt AC for resistive load and 5 amp at 250 volt AC for inductive load. For DC load, the rating is a bit lower. From the datasheet we can see it rated 8 amp at 30 volt DC for resistive load and only 4 amp at 30 volt DC for inductive load. No load with rating exceeding this should be connected to the relay, as these are the maximum rating values, and it's always good to connect a load with ratings lower than these maximum rating values. The other important parameter to consider when selecting a relay is the type of mounting and enclosure depending on your operating environment and the required mounting method. This relay model is fully sealed and is for PC board mounting. Connecting a relay to Arduino is super easy. You can connect it to any digital pin of the Arduino just the same way you would connect an LED. Because relay coils usually require more than 40 mA an Arduino pin can supply, that's why we can't connect them directly. We can use any low power transistor to do the job. In this example, we're gonna use a general purpose low cost NPN bipolar junction transistor. Its rated continuous collector current is 100 mA, which is more than the required 79 mA by the coil of the relay we are using. Diode D2 is a freewheeling diode. It is used to suppress the back EMF generated by the coil of the relay, which could damage the transistor. A diode connected across the relay coil in reverse bias can do the job. The LED one will switch on when the relay is energized. Controlling a relay from Arduino is basically the same as switching on and off an LED. This is a simple code we're gonna test our relay with. The relay is connected to D7. To turn it on, just send a high to that pin, and to turn it off, just send a low. In this example, we're gonna turn it on for 5 seconds and off for 3 seconds. Let us run the simulation. On for 5 seconds and off for 3 seconds. Now let's start creating the schematic of the board. We're gonna use Eagle. I'm gonna start a new project, file, new project. Here you can see our previous completed project. We're gonna name this one Easy Relay 1 Shield. Let us create a new schematic. Right click, new schematic, file, save as. We're gonna name it the same name as the project, Easy Relay 1 Shield. We're gonna start first by adding all the components from the library. We're gonna do this in fast motion to save time. You can refer to our previous tutorials in this playlist to learn in detail how to create schematic with Eagle Schematic Editor. We're gonna start with the Arduino board. We have completed our schematic. The next step is to lay out the circuit in board layout view. Now let us use the schematic we have just created and start building the board in board view. If you click on this icon here, generate switch to board, this will switch between layout and board view. So gonna click. It says the board does not exist, created from the schematic. This is because we don't have the board yet. Gonna say yes. All the components are connected together with this yellow line. It's called a wire. They just represent electrical connections between components, but they are not copper traces yet. Now we need to move all these components to this blank board using the Move Component tool. We're gonna start with the Arduino. To save time, I'm gonna place the rest of the component in fast motion. We have placed all the components. Now we can add some more information on the silk screen. This information will be printed on the top and the bottom of the board. We're gonna add the title to this board and some other few labels. Click on the text tool, student companion. Gonna place it on top. Gonna select the top place. The size is gonna be 1.6 millimeter. Easy Relay Shield. Even though this relay used is able to handle 10 amp, a 220 volt AC, for safety reasons we have downgraded this relay to only 48 volt AC and 24 volt DC at the maximum current of 5 amp. If you want to use higher voltage such as 110 volt or 220 volt, please consult a professional electrician to avoid risk of electric shock. The only thing remaining now is to route our A wires. This is a small board, so we're gonna route it manually. This is a manual route tool. Click on the route command. I have enough space on my PC board, so I'm gonna set the width of my low voltage traces to about 1 milliamp and the high voltage to about 2.5 milliamp. Gonna start with the top layer. The width, I'm gonna set it to about 1 millimeter. Let's start here. Right, we have routed all our traces. This was simple. It's a small board. Click on design rule check. This tool allows Eagle to check for some design errors. Set the clearance to 8 mm. Minimum width, gonna set to 10. Click check. There were no errors generated. Now the next step is to generate the Gerber files to manufacture our board. Great! Now we have reached the final stage of our PC board design. We now need to generate the Gerber files that we can send to our manufacturing house to build our board. Gerber files contain the data about our PC board, where traces, pads, holes are placed, their width, and so on. Because we've got different layers of our PC board, we'll generate different files for each layer. No matter which PC board design software you use, they should all produce standard Gerber files that should be understood by most PC board manufacturers. Click on this icon to access the CAM processor. CAM is short for Computer Aided Manufacturing. Eagle comes with a couple of templates that you can use. We're gonna use the SparkFun Gerber job template. Under the local CAM jobs, select the SFE GEB 274. To generate, click on Process Job. Specify the folder. Gonna create a new folder. Relay 1 Shield Gerber. Select. And that's all. Open the folder. These are the generated files. The GTL is the top copper. The GTS is the top solder mask. The GTO is the top silk screen. The GBL is the bottom copper. The GBS is the bottom solder mask. The GBO is the bottom silk screen. And this is our drill file. Now we are done with the PC board design. All we need to do is to zip all these files and to send them to your favorite PC board manufacturing company. Add to archive. Okay. Before sending Gerber files for manufacturing, it's always good to check them one more time with a Gerber viewer just to make sure that everything is correct to avoid some bad surprises. There are many free Gerber viewers that you can use, like GebView from getterproject.org. We're gonna send these Gerber files to PCBWay to manufacture our board. PCBWay is a China-based manufacturer specializing in PC board prototyping, small volume production, and PC board assembly service, all under one roof with more than a decade of experience. They offer quick turnaround PC board at a very budgetary price. For 10 PC board, they're gonna charge you $5, and for 1 up to 10 PC board assembly, they're gonna charge you $88. To order from PCBWay is super easy. You can do everything online. All you need to do is specify the dimension of your board. My board is 60 by 54. Specify the quantity. Gonna specify 10. Select the layer to 2 and the thickness to 1.6 mm. Click quote now. You can now specify some other few parameters. The solder mask, we're gonna select the blue color. The silk screen, we're gonna leave the default white. Click yes. Then click calculate. The standard build time 3 to 4 days. It's gonna cost us $5 for 10 PC board. If you prefer to get your board sooner, then you can select the Express 48 hours. It's gonna cost you $39 and the Express 24 hours is gonna cost you $62. Here you can select your shipping company. Each has its own cost depending on your budget and how soon you want your board. We're gonna select DHL. Now you need to select your country. This will be the total cost, but is still subject to their review. Click on Add to Cart. The next step is to upload the Gerber files. But if you design with Eagle, you can import directly the Eagle board file and use their online converter to generate the Gerber files. As we've already generated the Gerber files, so we're gonna upload them. Click on Submit now. The order will be reviewed. It can take 10 minutes to 1 hour to complete the review. Then I'm gonna receive a feedback if I can proceed with the payment or if there were problems with my files that I need to fix first. So click Submit. And that's all, guys. Now I need to wait for some few days to receive my PC board. These are the PC board we have received after some few days from PCBWay. It roughly takes 2 to 3 days to build your PC board and roughly 5 to 10 days for shipping depending on where you live and the shipping company you selected. The PC board quality is really great. We selected the blue solder mask which came out really great. I can see clearly all my markings on the silk screen. All the traces and solder points are clear and neat on both layers. PCBWay produces good quality PC board at a very low cost. With $5 you can get 10 PC board. To avoid disappointment in your design, always choose a reputable PC board manufacturing company like PCBWay. What's remaining now is to solder all our components and test our shield. Are you ready? Here's our Relay 1 shield. Let's plug it into the Arduino Uno. Just align the header pins. Then press. Everything looks great. All the components fit together. We use the correct component footprint. Let's just connect this light bulb to the relay. I'm gonna break one AC line, the live line. I'm gonna connect it to normally open and COM. Make sure the cable is connected properly before you plug it to the main socket. I'm gonna plug it to the main socket. Let's connect the power to the Arduino USB port. I'm gonna plug it to the PC. Just upload the code. Upload. There you go. The light is on for 5 seconds. It's gonna be off for 3 seconds. I can see the LED on the shield. It's also switching on when the relay is energized. Thank you guys for watching this tutorial. I hope you enjoyed it. We have taken you through all the steps to design a fully working Arduino Relay Shield. We have also shown you how you can manufacture cheap quality PC board with PCBWay. To get more information about PCBWay, click on the link in the description of this video to access their website. We also have another video in this playlist explaining all the steps to place an order with PCBWay. Thanks for watching. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. If you have any comment, you are welcome, and I'll see you guys in the next tutorial. Thank you.